This is the last and final part of the notes for this section. This is example 2. So we're given a triangle, ABC, and we're given it where angle C is the right angle, and it tells us a ratio. It tells us that the sine of A is 6/7. So I want to find a couple of these things. So first, I think what we'll do is we'll set up a triangle. So let's set up the triangle over here. I know it's a right triangle, so I'll draw that in. Here's my right angle. And let me label it A, B, and C. And it tells us that C is the right angle. So here we go. So I know that that's side C. And I know that this is side B, and I know that this is side A. And let's see if we can figure out what any of those sides are. But it gives us that sine of angle A is 6/7. So let's try to figure out what sine is. Well, sine is opposite over the hypotenuse. So sine of A, so here's A. Sine is opposite. Okay, well, A must be 6. And the hypotenuse, so C is 7. So I just need to do a little math to find out what side B is. So I know that 6 squared plus B squared is equal to 7 squared. The legs squared and add together is equal to the hypotenuse squared. So B squared is equal to 49 minus 36, and B is equal to the square root of 13. So that's just some algebra I did there. You should be able to get that, no problem. And let's write that in here. So B is equal to the square root of 13. So now I know all my sides, and I can go ahead and do any ratio that I'm asked for. So in this first one here, it says the secant of A. Okay, well, let's figure out what the secant is. And if I can't remember exactly, I might want to say, well, I know secant is 1 over the cosine of A. So it's reciprocal. So really what I'm doing is 1 over the adjacent over hypotenuse. Let's spell it out a little more. Adjacent over the hypotenuse. So the reciprocal is just going to be looking at the hypotenuse over the adjacent. So if I'm looking there, I'm going to look at secant of A. Well, here's A. I want the hypotenuse over the adjacent. Hypotenuse over adjacent. 7 over square root of 13. But as we know, we can't leave the square root of 13 in the denominator, so I'll multiply the top and the bottom by radical 13. And you can actually just skip this step if you know how to do it in your head. So we have 7 radical 13 all over 13. The purpose was to kind of square it to get it out of the denominator. So there's the secant of A. And let's go over cotangent of B. Well, I know cotangent is 1 over the tangent of B. And tangent, let's see, we can go 1 over. Now our tangent is opposite over adjacent. Opposite over adjacent. So I really want the reciprocal of that, which I'm going to be looking for the adjacent over the opposite. So let's see, oh, now we're switching to B. So now I'm over here. So I want the adjacent here, so 6 over the opposite, square root of 13. And I'll have to do the same rationalizing and get 6 square root of 13 over 13. And here's our cotangent of beta, or B. I'd be able to do this really for anything as long as I know the 3 sides and I know the 3 basic trig ratios. All I need to know is how to flip them for the reciprocal, and I have any of the 6 parts. Here's our last example. This is an example where we're kind of working on the coordinate plane now. So given the right triangle that connects the origin and the coordinate points -4, 3, find the cosine of angle beta, or cosine beta. So let's look at what this is saying. So here we have a right triangle, and it connects the origin with the point, oh, it should be pluralized, with the point -4, 3. So I know that -4 is my x, and 3 is my y. So this spot here is going back to -4, and up here, we're here at 3. So I can kind of translate that this is -4, and this length is 3. So we're actually going to incorporate the negative and positive aspect of it to find this cosine of beta. So let's see, cosine beta. So cosine of beta is equal to our cosine is adjacent over the hypotenuse. All right, well, my adjacent to beta, so the one right next to it, is -4. My hypotenuse, I don't have it, so I'm going to have to perform the Pythagorean theorem. So we can do that quick, but one thing that I'd like you to be able to remember is that, and we can call this C, 3 and 4 being my legs for a right triangle, I'm automatically going to get 5 here for my hypotenuse. That's a Pythagorean triple, and that's an important one to know so that you don't have to always do this piece of it, because it's a pretty common one that we find. So C is going to be equal to 5. It's a 3, 4, 5 triangle, and any multiple of that. So we'll write 5 here, 4/5. So our cosine of beta is -4/5. And again, we could find any of the ratios that we wanted, but here's a little concept of being able to work with negative and positive aspects of these. That's going to be more beneficial when we start doing the unit circle trig.